Hello, Algebra 1, and welcome back to what is arguably the most important lesson out of every lesson in Topic 8. If you struggled in Lesson 8.6, which was factoring by guess and check, today is for you. Today is how we determine or figure out how to factor any polynomial in ax squared plus bx plus c. Well, almost any. We'll see that in a bit. So, notice that our daily learning target is to discover the magic step to convert a polynomial from the form ax squared plus bx plus c into still ax squared and c, but these two middle terms. And remember, we called this the mystery or the magic step last class. I did it for you, and you put the four terms into the box. Well, this class, we actually get to determine how we find those two middle terms. So let's take a look at our opener. Our opener is kind of like a puzzle. They need you to find two numbers that meet both of the requirements. So, for example, on the first problem, they say list two numbers which add to make 6 and multiply to make 8, right? We need two numbers that do that. Now, you might be tempted to start with adding to make 6, but we need to realize that even though we're working with only nice integer numbers in this unit, there's no fractions or decimals, there's an infinite number of ways to make 6, right? Let me convince you. You could do 3 plus 3. You could do 2 plus 4. Those are both 6. 1 and 5 is 6. 0 and 6 is, of course, 6. And you're like, and that's it. But what about negative 1 and 7? That's 6. Negative 2 and 8, that's 6. There's an infinite number of ways to add to make 6. But what about multiplying to make 8? I think we're limited there. And really, for today, you're definitely going to want that factoring sheet. I have mine pulled up here. To multiply to make 8, you only have a couple combos. You have the positives here, and then you could also do the negatives as well, right? Those also multiply to make 8. But there's really only 4 possibilities. So looking at those 4 possibilities, which ones add to make 6? Well, this adds to make 9. That makes negative 9. That makes negative 6. I think the only two are 2 and 4. So my answer here, which numbers add to make 6 and multiply to make 8, are going to be 2 and 4. And I'm just going to show this like so, right? 2 plus 4 equals 6, and 2 times 4 equals 8. They do both. So go ahead and pause this video, use that factoring sheet, and let's see what else you can come up with. Right? There are 5 more of these. That factoring sheet's going to help. Unpause. We'll go through it together. Ready, set, go. Okay. Problem 2. List two numbers which add to make 2 and multiply to make negative 3. Now you'll find if they multiply to make negatives, like many of these do, it's actually a little bit trickier. So multiply to make negative 3, add to make positive 2. The reason it's a little bit trickier is because there are 2 ways we can multiply to make negative 3. Either negative 1 and positive 3, or positive 1 and negative 3. If we try both of these, right, and we add them together now, negative 1 plus 3 is positive 2, 1 minus 3 is negative 2. So I think this is going to end up becoming negative 1 and positive 3. All right, so let's put this out here. Negative 1 and positive 3. We always want to check. And we say, well, negative 1 plus 3 is certainly 2. And negative 1 times 3 is negative 3. That looks good. Multiply to make negative 12. I'm going to start with that. Add to make negative 1. Let's see, here's 12. We need to multiply to make negative 12. So one of these has to be negative. If they're both negative, the answer becomes positive. And add to make negative 1. Now, one advantage is if you multiply to a negative and they have to add up to something, that actually means that the difference between the two numbers is what they add up to. For example, 12 and 1, the difference is 11, and negative 1 plus 12 is 11. Because these are 11 apart, I knew right away those weren't the right ones. In fact, 4 and 3 are only 1 apart, so I bet we have 2 combos, either negative 3 plus 4 or 3 plus negative 4. Which one of those is negative 1? That's got to be this guy, 3 and negative 4. So we jump over here and we say, okay, this is going to be 3 and negative 4. So they do add. 3 plus negative 4 is negative 1. And they also multiply. 3 times negative 4 is negative 12. So since you get the idea, I think I'm just going to go through and try and spoil the rest of these. We don't need to go to the factoring sheet every time. So multiply to make negative 12, add to make negative 11. I think that's negative 12 and positive 1. Right? We can check it though. Negative 12 plus 1 is certainly negative 11. Negative 12 times 1 is negative 12. Here's another negative 12. We're not getting sick of these yet, are we? I think this one's probably going to be positive 6 and negative 2. Right? 6 times negative 2 is negative 12. And we have 6 plus negative 2, which is 4. Last but not least, negative 18 multiply to make 72. This one could be a tough one. Let's go ahead and jump down to 72. I know 72 has lots of factors, so probably it's a good one to finish. Which ones are 18 apart? These aren't 18 apart. I don't think any of these are 18 apart, but do they end up add to 18? I think these guys add to 18, don't they? 6 and 12. So let's see if we can make this work with 6 and 12. Jumping back up here. We have to multiply to make 72, so you might think 6 and 12 will work because 6 times 12 is certainly 72. However, 6 plus 12 is not 18. But never fear, if you want to keep the multiplication the same answer, make both numbers negative. Now, negative 6 plus negative 12 is negative 18, and we have our two numbers. Okay, there is a reason that we just spent time on that. Actually, that's probably the most important thing you need to be able to do today that's new. But before we understand why, let's go ahead and backtrack. So, hopefully you realize that although we can find the answer to factoring problems through guess and check, it might be nice if we had a surefire way that would work every single time. And we started this process last class. There are 2 steps, and so here's a reminder of those 2 steps. Step 1 is you need to take your quadratic trinomial, and that's in that ax squared plus bx plus c, and currently this has 3 terms, right? You need to rewrite that so it has 4 terms. That means we're going to take this bx term and split it into 2 different terms that are still added up to bx. However, you have to split it just right. If you don't split it just right, then your algebra tiles that we saw last class won't make a perfect rectangle. So the magic step is what we're going to focus on today. Step 2, though, was the easy part. Once we had our polynomial in 4 pieces, we factor by grouping, and we used the box last class. It says that was lesson 8.08. That was really 8.07. Awkward typo. We'll do it like this, 8.07. Okay, so let's go ahead and try this. Try to put 2x squared minus 7x minus 4. Can you figure out what the 4 terms are? Let's give it a shot. So we have 2x squared, we know goes in the upper left. Negative 4 goes in the lower right. But then this negative 7. Well, think about how you could split negative 7, right? Can you think of ways that we could get back to negative 7? Okay. Well, I could do something like, I don't know. How about maybe something like negative 8x and negative 1x. Right? That looks pretty good. But I think negative 8 plus negative 1 is actually negative 9, so that would have to be a positive. So that would be okay. What about if I wanted to do like negative 4x and negative 3x? That would be okay too. In fact, those are pretty small numbers, so let's go with that. Okay, let's see if I got it right. Well, 2x squared and 4x, they each have a 2 in common and an x. 2x times x is 2x squared. 2x times negative 2 is negative 4x. X times negative 3 is negative 3x. It's looking good so far. Let's check the bonus box. Drat. Negative 2 times negative 3 isn't negative 4, which means that this is not the way to factor. Right? And there's so many different ways to write negative 7x. We could do negative 10x and positive 3x and so on and so forth. But I'm not going to try all those because that sounds obnoxious. So what if instead I told you how to write this? What if I told you, it was actually the one before, I told you it was negative 8x and positive 1x. So let's try that box method, right? Looking pretty good so far. 2x squared, negative 4. Remember, the order of these doesn't matter. Negative 8x and 1x. Let's see what these have in common. 2x squared and 8x, they each have a 2 and an x. 2x times what is 2x squared? That's 2x times x. This one's got to be negative 4. This one's got to be 1. And bonus box, phew, that one checks out. So the correct way to factor then is, of course, 2x with a positive 1 and x with a minus 4. Hooray! Okay. Now, how did I know to rewrite that? I don't know why there's an equals 0 here. Sorry about that. How come I didn't write it as negative 2, negative 5, or negative 10 and 3? Well, we really covered that. If you try it in a box, those ways just won't factor. Sad day. Okay, so let's skip to the next page. The previous problem might have given some insight on how to write a trinomial as a polynomial with 4 terms. But here comes some spoilers. Right? If you don't want spoilers right away, maybe we can look at this quickly, right? Maybe, just maybe, you might notice that if you multiply these diagonals, right? If you do 1x times negative 8x, that equals negative 8x squared. And if you multiply this diagonal, you do 2x squared times negative 4, that also equals negative 8x squared. If you had tried that over here, this one would certainly equal negative 8x squared, but this one, 4 times 3, would equal 12x squared. Different numbers. Do you think that's it? And it turns out that, yeah, that is it. There's actually a proof that says in a perfect rectangle, the diagonals are always going to multiply to equal the same number. And so that actually gives us the last piece of the puzzle to split a trinomial into 4 terms. So let's take a look. Given a trinomial, ax squared plus bx plus c, split your bx term into 2 terms. We know that these 2 terms, whatever they might be, right, are going to add back up to equal bx. Okay? Now, I'm just going to call them b sub 1 and b sub 2, just to show that they're related to the b values, but they're generally different numbers and they add back up to equal the b. But here's the really important part. If you take those same 2 numbers, right, and those are the 2 numbers that I circled in yellow up here, if you take those same 2 numbers and you multiply them, they are going to equal the multiplication of the other diagonal. Now, the other diagonal was made up of ax squared and c. So what we can say is, and I'll show these in blue up here, that these 2 have to multiply to equal ax squared times c, right? So not only do the 2 terms you split your b term into have to add back up to equal b, they also multiply to equal a known value, right? They're going to equal the same answer as when you multiply ax squared times c. Now, do you see how this looks like the opener? We are going to be looking for 2 numbers that multiply to equal something we know, and 2 numbers that add to equal something that we know. Once we solve that puzzle, and it's no harder than the opener, that tells us what these 2 values are. We can now split our polynomial into 4 pieces. I keep saying 8.08, it's 8.07. The 4 pieces would be this: ax squared, and c go in our box, and the 2 b pieces, I'm going to say b sub 1 of x and b sub 2 of x, go on the other parts. You, of course, finish by finding the outside of the box. Now, this was pretty general, so we might want to be a little bit more specific here. So let's look at a nice example. Okay? We are going to factor 6x squared plus 13x plus 6. And I'll tell you right now, this is not something that I'd want to factor by guess and check. I don't want to do guess and check here because of all the options. This could be 6x and x, this could be 3x and 2x, and then 6 has multiple different ways. Nope, sounds like a headache. So, let's get it done. We are going to try to start by fitting 6x squared and 6 into the box. Okay? Those fit just fine. But my 13x does not. There are 2 spaces left. I know, though, that whatever these 2 guys end up being, they better add back up, and I'll just do it like this. They better add back up to equal bx, right? Or in this case, 13x. Also, though, I know that when I multiply those 2 guys, they're going to multiply to equal the other diagonal multiplied. So the other diagonal is 6x squared, I meant for that to be blue, is 6x squared times 6. And if you multiply those, that's 36x squared. Okay, so the game we need to play is what are the two numbers that multiply to equal 36 and add to make 13? Now you have your factor sheet over here. This makes it really easy. We're going to look quickly at the factors of 36 though. That's on our first side. And notice that there are a bunch of them, right? 1, 2, 3, 4, 5 different factors here. Okay, 1, 2, 3, 4, and 6. I think I can get all those. Let's get them written down. We have 1, and I'm going to put just the 1 and I'm not going to include x's here. 1 and 36 multiplies to make 36. 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay. However, there's a second set of factors. -1 and -36, -2, -18, -3, -12, and so on so forth. Okay. Those are the 10 possibilities that are going to go, and I probably should have done those in yellow, in the other two diagonals. How do we know which one it is if there's 10 possibilities? Well, don't forget, we are splitting up 13x. So which of these adds to equal positive 13? Certainly it's none of the negatives, right? Can't be any of those. Those all add to equal a negative. Let's look at the positives. 37. This one is 20. 15. This one is 13. Oh, hey-oh, 13. That's what we want. That one's 12. So 13 has got to be our answer. That means we're going to split 13x into 4x and 9x. At this point, the rest is history. The rest is last class. Let's get it done. 6x squared and 6 are already in the box. 4x and 9x in any order. And now we find the outsides. 6 and 9 both have a common factor of 3. They also have an x. 6 and 4 have a common factor of 2 and x. And 3 times 2 is 6. 3x times 3 is 9x. 2x times 2 is 4. Bonus box, 2 times 3 is 6. Therefore, this factors into 3x plus 2 and 2x plus 3. Now, I realize you're probably saying, well, wait, that seemed like a ton of work, right? Way more than guessing and checking. And on one hand, if you do all this work, it is. But on the other hand, we won't actually need to do all this work every time. And I'll show you what I mean on some practice problems down below. Okay? So what I'd like you to do for problems 1 through 8, 10, 1 through 10 here is don't even worry about the box part, or at least the outside of the box. I just want you to focus on the inside. In fact, what I'd like you to do for each problem right now is I'd like you to draw the box and set up half of the box, right? We know that 6x squared and 3 for this first problem are going to go in the box. 6x squared, 3. Don't even worry about the 19x. We'll get back to it. Same thing for the second problem. We'll set up this box. We know that, let's see, 3x squared and 2 have to go in the box. So pause this video, take 30 seconds to a minute, set up your box for each problem, and then we can come back together. Ready, set, go. All right, you're back with me. Notice that I went through and set up my box on each one of these just so we're ready to go. And you might be wincing at this and saying, oh my gosh, we have to do 10 of these problems. We're going to do a lot more, guys. You really need to be comfortable with this trick, and as we know, practice improves performance. The more we practice, the better we perform. You can start to show less and less work the more comfortable you get, and at the end you're going to get a chance to both guess and check and use the box. But here's what I need you to do next. We're not even doing the full problem. What I'm going to have you do next is figure out what goes in to these two diagonal boxes. Now, realistically, 19x goes in there. But how is it going to split? Will it be 18 and 1? Will it be 16 and, 16 and 3? Will it be 14 and 5? So on and so forth. To do that, I always write this out in 2 steps. We know that these two boxes better add back up to equal 19x. right? That's the whole point. When you combine like terms, you get 19. However, and here is our shortcut. We also know that when we multiply this diagonal, it has to equal the other diagonal multiplied. So what do you get if you multiply 6x squared and 3? Well, that is going to give us 18x squared. And now we play our factor game. What multiplies to equal 18 adds to equal 19? Well, you can use your factor sheet or your knowledge of factors. It's up to you. I'm going to look up 18 though and say, which of these three can combine to make 19? No way 3 and 6 makes 19. 2 and 9 doesn't make 19. Ooh, 18 and 1 does though. We are using or talking about 1 here. So we're going down here. I believe that this is going to be 18x and 1x. 18 plus 1 is 19. 18 times 1 is 18. And so I have now found the inside. We have found that 19x will be split up into 18x and 1x. Or in an equation, it's going to be 18x and 1x. I'm not even going to find the outsides. In fact, I don't want you to find the outsides yet. I just want you to find the full inside of the box. So there are 9 problems to go. You're just finding the inside. If you get stuck on any, ask your group, ask your teacher. Once you're all the way through, you can unpause. You can check your answers with mine. And then you are going to move on to the actual factoring part. Ready, set, go. All right, you're back. I'll go through this one pretty darn quickly. You also might notice that this says 3x squared and then 2x squared here. Should probably say 3x squared. Let's get to it. So here's my thought process. We need to split 7x into these two boxes, so it's still going to add to 7x. But they also need to multiply times these diagonals, and 3x squared times 2 is 6x squared. What multiplies to make 6 adds to get 7? Well, I believe that's 6 times 1 and 6 plus 1. So 6x, 1x. Next up, 5x squared plus 11x plus 6. You have a little bit more freedom here on how you want to show your work. I'll tell you that some of your classmates are going to be talking about this cool Xbox method that they learned. And that's great. I'll show you what they mean. The Xbox method that they talk about is they'll do an X like this, and they'll put it's been a while since I've done this too. They will put the 6 here that they want to add to, and then they will, nope, that's wrong. They will put the 11x that they want to add to, and they will multiply 5 times 6 to get 30. That's what they want to multiply to. Now, all they're really doing is they're taking these two blanks and they're saying these two blanks have to add up to equal 11x, and those two blanks also have to, can you see it, multiply to equal 30x squared. It's the same thing. So we find our numbers. I believe this will be 5 and 6, because 5 plus 6 is 11 and multiplies to get 30. And then they put their 5 and 6 here and put it all into the box. That's great. The X looks cool. I just don't write it out. I just write it like this and then put them in the box from there. It is up to you on how you want to show this work. If you find another video that works for you, that's great. Let's try another. 9x squared and 4 this time. So we need two numbers that add back up to equal negative 15x. And the same two things have to multiply to equal, can you see it? We have 4 times 9. That is 36x squared. All right, let's see. To get 36, I think 9 and 4 is pretty good, but that makes 13. I think 18 and 2 is pretty good. That doesn't work either. What else makes 36, guys? 1 and 36, 2 and 18, 3 and 12. Oh, I bet it's 3 and 12. Let's try it. So we have 3x and 12x. And to combine those together, negative 3x and negative 12x makes that. So I think these need negatives. There we go. Negative times a negative is a positive. Awesome. Negative 3x, negative 12x. Okay. Let's keep on moving down. We know that these guys have two numbers that have to add to equal negative 9x. And they have to multiply to equal these two. So 14x squared. All right, well, to get 14, there aren't too many ways. I bet it's going to be 7 and 2. 7x and 2x, 7x and 2x. Oh, but wait, we need to make a negative 9. Make them both negative. Both negative. Negative 7x, negative 2x. Okay, just a couple to go. And I'm trying to show this in all sorts of different ways of how I arrange my factors. It's up to you. We're trying to split apart negative 16x. So these need to add to make negative 16x. And they need to multiply to equal, there it is, 15x squared. Let's see, to get from 15 to 16, I think it's got to be 15 and 1. That is going to add to make 16. Negative 15x, negative 1x. Awesome. So these ones both need to be negative here, and we're good. 4 to go. Okay. These ones are ending in negatives. You'll notice that most of ours ended in a positive, and that makes this a little bit easier. When they end in negatives, just like the opener, you're going to find that it's a little bit trickier. That's all right. We got this. So these two have to split up the 2x, and they are going to have to multiply to equal these guys, which is negative 3x squared. Well, this one's got to be 3 and 1. That's the only thing I can think of to multiply to make 3. We know one of them has to be negative to equal a negative. But which one? Well, let's jump over the 2. The 2 is positive, so the bigger sign wants to keep that positive, so give it to the smaller one. 3 minus 1 is 2. 3 times negative 1 is negative 3. 3x, negative 1x. Let's try again. We now have, and I'll do this one down below, two numbers that have to add to equal this 1x up here, and they have to multiply to equal negative 56x squared. Well, because there's a negative, that tells me that these numbers have to be 1 apart from each other. Aren't 7 and 8 1 apart from each other? So we have 7x and 8x, which look pretty good. One of them has to have a negative though. So to make a negative, let's see, this is a positive, so keep the bigger term positive, give the 7 the negative. Okay? Negative 7x, positive 8x. Actually, the reverse of what was over here. Reverse, reverse. All right, 2 to go. Back to positive land. All right. We know the two numbers have to add to equal negative 11x, and they have to multiply to equal 4 times 7 is 28x squared. Well, I bet 7 and 4 probably jumps out at you. And if you combine 7x and 4x, it makes positive 11. Let's make that negative. Okay, let's make both of these negative too. Negative 7x, negative 4x. Last one. Negative. A little bit trickier. So two numbers that add to make negative 13x, and they multiply to equal, this is negative 14x. Well, if we're going to make 13, the numbers have to be 13 apart. 7 times 2 is 14, but 7 and 2 aren't 13 apart. So instead, I think we have to fall back on everyone's favorite, 1. 14x and 1x. 14 times 1 is 14, and I think we can combine them to make negative 13. The answer is negative, so make the bigger number negative, and we're good. Negative 14x and 1x. This is the main point of today, finding those two terms. Now that we've found those two terms, the rest should be pretty easy because this is what we practiced all last class. So go ahead, pause the video, and start finding the outsides so we can actually put this bad boy in factored form. Right? And if you want a quick example, nothing too bad. You start with any row or column. We find the common terms, 6 and 18. You can use your factor sheet. They both have a 6 in common and an x. Then we start multiplying. 6x times x is 6x squared. 6x times 3, x times 1. Bonus box. Yeah, we did it. Looks pretty good. And so my factored form is 6x with a positive 1, x with a positive 3. Okay, go ahead and pause me. Once you're done, unpause. We'll talk about the rest of these problems and then the ones at the end. Ready, set, go. All right, we're back. Let's go ahead and take a peek at the last few boxes, the last 9 boxes. We're going to get in the groove here. If you're pretty confident on this, you should watch this at like 2 times speed or try the problems at the end while you're waiting for me. Let's see. I know that 6x squared and 3x, or 3x squared and 6x have a 3 and an x in common. 3x times x is 3x squared, 3x times 2, x times 1. So 3x with a positive 1, x plus 2. Next one. Oh, 5x squared and 5x, that's an easy one to start with. 5 and x. 5x times x is 5x squared. 5x times 1, x times 6. Bonus box, 6 times 1 is 6, we're good. And so my final factored form, 5x with a positive 6, x with a positive 1. So notice too that there really is not a lot of work here, right? The work was we had to set up a box, which we're pretty good at, write out two statements, adds, multiplies, and then find the outside. Now sometimes it is still faster to guess and check, right? For this guy, I probably could have guessed and checked pretty quickly. I could have said 5x and x has to be those, and then it has to multiply to get 6. So I bet this will have to be a 2. 2 times 5 is 10, and this will have to be a 3, and I would have been wrong. Drat, okay? So that didn't work out at all. That's a bummer. And so maybe instead I would go with like 1 and 6, and that looks pretty good. This is 5 and 6, which makes 11. All right, we guessed and checked. So don't forget about guessing and checking. It is almost always faster, okay? But that's all right. Let's go ahead and keep doing this box method. All right. Let's see, 9x squared, 3x. Because this is positive, keep the terms here positive. It's going to make your life easier in the long run. 3 and x. 3x times what is 9x squared? Well, that's another 3x. That's because 9 and 12 also have 3 in common. 3x times negative 1. 3x times negative 4. And they multiply to make positive 4. Great. Factored form, 3x minus 4 times 3x minus 1. Moving on. These ones both have 7s in common. That's easy. 7 and x. 7x times x. 7x times negative 1. Negative 2. Bonus box. Negative times a negative is a positive. Checks out. 7x minus 2 times x minus 1. Next one. A little bit trickier. You could say that those have 3 in common, or you could say that these ones don't really have anything in common besides the x. That makes this a 3x. Negative 1, negative 5. Bonus box looks good. And so we end up with 3x minus 1 times x minus 5. 4 to go. This looks like a 3x. 3x times x. 3x times 1. X times negative 1. They multiply, they look good. Don't forget to write your answer. 3x minus 1 in parentheses times x plus 1. Okay, now some students have said, well, you go so fast through these. Well, I am, because you guys have already done these, right? You should have paused the video and taken as long as you could to actually figure out the factored form. And then you unpause, and I'm just running through it really quickly. Maybe there's something small you missed, but you shouldn't be trying to keep up with me. I've been doing this for 12, 13 years now of teaching. I'm pretty good at it. You guys, when I ask you to pause, should have paused and taken your time. All right, 7x and x. 7x times negative 1, x times 8, and we work out just fine. Okay, I didn't have room to write my answer at the bottom, so we'll put it at the top. 7x plus 8 times x minus 1. 2 to go. 4x and x, negative 1, negative 7. Final answer, 4x minus 7 and x minus 1. Last but not least, 7x squared and negative 14x. They each have a 7 in common. 7x and x, negative 2, 1, bonus box, and we're set. 7x plus 1 times x minus 2. Oof. We got some good factoring done here, guys. I am excited and proud of all of you. All right, the last part of today is to remember that oftentimes guess and check is faster. I guess and check probably 95% of the time. In fact, every problem that's written down below is almost certainly one that I would guess and check on. Okay? If you're not guessing and checking and you use the box every time, that's okay too. Whatever works well for you. The box method is awesome because it works the same way every time. Guessing and checking is messier, but it's faster. How is it faster? Well, look at, let's just say problem A right here. If I wanted to factor A, I'd know it'd have to be 3x and x to make 3x squared. To get negative 5, I bet this is going to be negative 5 positive 1. That's 3 minus 5. There it is. There's my final factored form. Now, could you do A doing the box? Of course you could. And should you do it doing the box if you are not comfortable with guess and check? Of course you should. So here is A. We would go through. We'd start to set up the box. We would say this is 3x squared and negative 5. We know that our two numbers inside the box that we haven't done yet are going to split up the negative 2x term. And they have to multiply to equal the same diagonal. So they're going to have to multiply to equal 3 times negative 5, negative 15x squared. Using your marvelous factor chart, we can see that these have to be, it looks like, negative 5x and positive 3. Negative 5 plus 3 is negative 2. And now we're on the home stretch. So it'll be 3x and x, negative 5 and 1, and we're good. 3x minus 5 times x plus 1. So what I'd like you to do for the rest of class today is to go through and try B through H. You might find that some of these are a little bit trickier than others. Once you've attempted each of those, you're going to unpause, come back here, and I'm just going to give you the answers, maybe talk about anything that's weird on here, and that's that. All right, good luck on these last few. Only unpause once you've tried them all. Ready, set, go. All right, you're back. I'm going to do each of these with guess and check, and I'll take you through what I'm thinking as I do it. Again, I don't remember how these factor, honestly, off the top of my head. I think that's a little bit more realistic for you guys. So I see the 2x squared. That's all I'm looking at. I know it's got to be a 2x and an x. Okay, as we go through here to make negative 9, I know that's probably either 9 and 9, but 9 times 2 is 18. That's way too big. Probably 3 and 3. Okay, we know this is a positive 3, so I bet that'll be a positive to get a 6x. 6x is here, minus 3x, and that looks pretty darn good. Next one, C. 2x squared again. How exciting. 2x and x. Okay. And then something weird is going to happen here, but I'll show you in a sec. So to make 4, 2 and 2, or 4 and 1. Okay. Let's see here. 4 and 1. It's going to be 8. And 1 is 7. We're getting something really interesting here, aren't we? Okay. I think actually you're going to find that this problem actually doesn't factor. And even when you use the box, and let's look at C here really quickly. 2x squared minus 8x plus 4. 2x squared minus 8x plus 4. If you can't get it through guess and check, go back to the box. See if it works. It might not. Okay, so box-wise here, at least if it doesn't work, you'll know for sure this doesn't factor. 2x squared and 4. Okay. Now, looking at this, you might say, okay, we need to split up the insides. We know that they are, of course, going to add to equal negative 8x, and they will multiply to equal, these guys, 8x squared. Can you find anything that multiplies to make 8 and adds to make negative 8? Well, I think the only two things that multiply to make 8 are 1 and 8 and 2 and 4. And neither of these add to make 8. So as soon as you get those, I'm pretty convinced this isn't going to factor. Or will it? How soon you forget lesson 8.5. Lesson 8.5 told us if there's something common to all three of these, we should still factor that out. And I think there is something common to all three of these. Isn't there a 2 that we could at least factor out from all of these? This would leave me with 1x squared minus 4x plus 2. And yeah, this is still part of factoring. In fact, over the next few classes, we're going to talk about how to combine this idea along with the box method. But we don't want to forget it. All right, let's look at D. I'm going to try my guess and check first. We have 5x and x. See, to get 12, we have to get up to 19. I would originally guess 4, but that's 20 and 3. That's going to be too big. What if I went the other way? What if I went 4 and 3? 3 times 5 is 15, plus 4 more is 19. That's the one. Should have gotten it whether box or guess and check. Let's try E. Same idea, 2x squared, not bad at all. 2x and x. We have to get 11, so this has to get really big really quickly. So I bet 5. 5 times 2 is 10, plus 1 is 11. 2x squared plus 5x plus 2, another 2x squared. How kind. 2x and x. 5 isn't very big, but neither is 2. So I bet 2 will work. And I know 2 couldn't go here because they don't have a common factor. And this is probably 1. 4 plus 1 is 5. That's lovely. 2 to go. Okay. My screen is also freezing, so it's harder to roll over. There we go. I'll probably put in that -1 here just so I don't get confused. I know this will be x and x. Let's see, multiply to get -12, add to get -1. I know this one already. It's going to be -4 and +3. For some reason, this one comes up all the time. This is -4 plus 3. That's -1. Last but not least, this guy. There's that invisible 1 again. Let's see. We know it's going to be x and x. I think there's only one way to make 1. That's 1 and 1. But now we have an issue. This is 1x and 1 more x. That's 2 x's. 2 x's does not make 1x. Let's go to the box really quickly and see if I messed up. X squared plus x plus 1. X squared plus 1x plus 1. Here is my box. We have x squared and 1. We need to split this guy up. So two things that add to equal 1x, and these same two terms need to multiply to equal 1x squared. What's the only thing that multiplies to make 1? Well, it's just 1 times 1. 1 times 1 definitely makes 1, but 1 plus 1 does not. There's nothing. This guy does not factor at all. So we can just say non-factorable, does not factor, something like that. Now, it turns out, and this is kind of like when we did the square roots of negatives, saying does not factor is not quite right. This year, though, we only try and factor with nice integer numbers, no fractions, no decimals. This will factor. However, it might only factor with decimals or even only with square roots. Yeah, you can factor with square roots too. And that's too far into what we go through this year. So for now, we're just going to say does not factor. Thank you for joining me today. I appreciate you hanging in there. That box method is so powerful, so useful. You'll use a combination of that and guess and check for every math class that you're in for the rest of high school. So make sure you're comfortable with it. If you aren't, ask questions, ask for clarification. We've really learned all the hard stuff. The last 3 lessons, 9, 10, and 11 for this unit, are just going to be some tips and tricks to get to the answer. So, tune back in for next class, and we'll make you a factoring expert in no time.